IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. In this episode, I talk to Sanjeev Aggarwal, President and CEO of Everspin Technologies, where we discuss MRAM technology, its use cases, and how it is shaping industrial IoT for the better. Hello, everyone. Welcome back to the third series of IoT Unplugged. I am delighted to be joined by Sanjeev Aggarwal, the CEO of Everspin Technologies. Sanjeev, thank you very much for joining us today.
Absolutely, Caitlin. Thank you for the opportunity.
So just to start us off, Sanjeev, could you introduce yourself and talk a little bit about your role and your background in the IoT industry?
Sure. I am the president and CEO of Everspin Technologies. I've been working in the area of memory, specifically non-volatile emerging memories since my PhD that I completed in about 1995, 1996. So about 30 years in this industry. First, I worked on ferroelectric memories. I actually helped bring that to production at Texas Instruments. And since then, I've been at Everspin, which was formerly Freescale, which is when I joined in 2006. In 2008, we formed this company, Everspin, spinning out of Freescale Semiconductor. At that time, I was actually in the process integration role, process engineering role. Since then, I have transitioned into the VP of manufacturing, leading the R&D team after that, leading operations for a while before I came to this position of CEO in 2022. And the reason I mention it is because that gave me an opportunity to learn about various aspects of Everspin. What does it take to actually build this technology? What does it take to actually commercialize it? What are the challenges faced by each of the teams that work on this project?
Great. Thank you very much for that, Sanjeev. We're here to talk about MRAM technology. In your opinion, how does it compare with traditional memory solutions? What are the major differences?
Yeah, so MRAM or magnetic random access memory, there are at least two flavors of the technology out there. One is field switched MRAM, what Everspin calls toggle MRAM, and then current switched MRAM, which is the spin transfer torque MRAM, which is being talked about a lot more nowadays compared to the toggle MRAM. But the unique features of MRAM is it actually combines persistence. Persistence basically meaning you can take the power off and the memory will retain its information. So it combines persistent with data security and integrity at very low latencies. So basically 5 to 10 nanoseconds, 25 nanoseconds, you can actually read and write this memory and combine all of that with unlimited read and writes or unlimited endurance. So it makes the technology pretty unique and positions it very well for industrial applications, IoT applications, data storage. It even has some reaching applications in AI inference on the edge, and we can talk about that going forward.
I like the use of the word flavors. I thought that was a nice touch. Sanjeev, you spoke about the fact that you've worked in this industry for 30 years. I guess I'm curious to get your take on the demands or the requirements on memory technology today.
Yeah, so if you look at memory today, it's actually evolving or it has evolved in a way that's actually central to compute technology. What that means is if you're trying to do any AI, if you're trying to do anything in the storage, in the data centers, memory is central to it from a hardware point of view. Obviously, there are software aspects to it, but from a hardware point of view, it is central. Now, it depends on what you're trying to do with the memory. For example, if you're trying to do storage, there is a memory flavor called NAND flash, and that's actually pretty critical to the application. It's basically cheap, and it is actually very available in very high densities. Now, if you're looking at the workhorse or the working memory, that's the DRAM, and that's been so for the last 30 years, and that's what actually drives all the compute, all the working memory in the application. And then you can rely on SRAM, which actually where over there you actually leverage the high speeds of the memory. So basically, you're looking at storage, you're looking at working memory, and then you're looking at latency or high speed execution. The great thing about MRAM is it can actually replace all of these memories if depending on how you tune the technology. And that's what makes it very attractive to the storage industry, for example. Low latency and persistent, unlimited read and writes. Look at NAND. Obviously, there is a cost structure over there that prevents MRAM from making a big impact, but it can actually be persistent and it can have unlimited read and writes. And in terms of SRAM, just like SRAM, MRAM has very low latency and it brings to the table persistence as well as unlimited read and write cycles. So the memory has a wide application or a wide impact on everything that we do today. And fortunately for Everspin, MRAM can play a role in all of those aspects.
It might be a good point to talk more specifically about these applications or use cases. Where do you see the use cases for MRAM technology, and kind of what are the requirements of these different sectors or markets that use them?
Yeah, that's a good question. So let me start with some applications. So for example, MRAM is widely used in the industrial markets. So let's look at the robotics. There are these computers called programmable logic controllers or PLCs that actually control all the robots on the manufacturing floor. Today, if you were not using MRAM, you're using a conventional technology like NVSRAM or SRAM. If you lose power, anything that is being done on the floor when you lose power, that entire material in the line is scrapped. Now with MRAM, as soon as you lose power, you can actually write back to the PLC the position of all of the robots. And what that does is when the power comes back on, you can start exactly where you stopped. So you actually prevent scrap on the line. The other thing is smart grids. Our MRAM is actually used in the smart grids, and what that basically does is it allows you to switch the control of the power from one type of energy to the other when appropriate. Another one is CNCs. It's basically a numerical calculator, computers that do the numerical calculation to control precision mechanical instruments that are being built for the industry. And again, over there, it's a similar argument as the robotic automation that I was talking about. So we have pretty far-reaching applications in the industrial space. The other application is, for example, in the DRAM space or in the storage memory. Same example. If you lose power, anything that is there on the servers, if it is not backed up quickly, all that data in flight is lost, right? So what MRAM can do is, because of its low latency or fast ability to read and write, you can actually store all the data into the MRAM and then over time download all the data into the NAND, which is the preferred storage technology because it's cheap. But MRAM actually secures all the data in flight or secures all the data that could have been lost if you were using a traditional technology like DRAM or flash.
Yeah, I think going back to this example you gave of robotics in factory, it sounds like there's a huge amount at stake if the power goes out and things aren't backed up.
I mean, for example, to name some of our customers, Siemens is actually using our technology and they've been using it for a while. Another customer is Schneider, both of them based out of Europe. And then also in Japan, our customer Omron is using the same technology. And the idea over there is just like we talked about, they want to secure everything that they have on the manufacturing floor. The value of the work in progress of the WIP is just too high to lose it. And that's why they use this memory.
Very good point. I think it's a good segue into looking or discussing the challenges you're looking to address when you're launching new MRAM technologies. I can imagine you have customers coming to you all the time with a particular issue. So do you mind summarizing some of those challenges?
Yeah, absolutely. So first, I'll start with the fact that at the end of the day, it's an emerging technology, right? So people need to get used to it, or people need to feel that it's actually a reliable technology before they're actually going to deploy it. And then if there is only one supplier of MRAM, for example, Everspin, then it even creates more challenges. So those are some of the challenges that Everspin has been working through over the past few years to actually get to our customers. The good thing is that we are very, very conscious about quality. So we have shipped about over 150 million parts over the last 10 years or so, with basically very low RMAs or very low returns or very low failures in the field. You can basically single-digit DPPMs, for example. So it's pretty high reliability, pretty good quality, and because of that, our customers, when they actually start using our parts, uh, the part basically sticks. The customers rarely actually design us out compared to the other technologies. So the other thing that I mentioned was, it's a new emerging technology, and if you are the only supplier, how do you get around it? So what we have done is we have made our parts socket compatible with our competition. So if you wanted to use an NVS RAM or ferroelectric memory or FRAM, our parts are socket compatible, which means you can take out an FRAM and put an MRAM, or vice versa. and the system would be oblivious to it. And that's what makes it easier for our customers to actually deploy this technology and use it on their floor.
That's really interesting. Seeing hearing how you got around that.
Yeah, I mean, we're working with the competition in some sense to help us out while we're competing with them for the market space as well. So it's been an interesting journey for us. Yes.
Yes, I can imagine. And where are you seeing the greatest potential for growth, both in relation to, geographical regions, but also in relation to applications? I know you mentioned industrial IoT earlier, for instance.
Yeah. Yeah. So one of the things to think about is I'll talk about two things. One is AI inference, and the other one is we're going to talk about this flash memory that is used in FPGAs, or it's basically what we call code memory or boot up memory. So anytime you boot up a device, there is some preset information in the device, and that is actually stored in this memory that we call flash, right? So that flash actually stopped scaling at 40 nanometer CMOS. So we needed a different solution beyond 40 nanometer. And that's where Everspin's MRAM comes into play. We actually offer standalone MRAM at 28 nanometer, and we're planning to scale it as well. So what that does is it actually gives our customers a scaling roadmap, continue to use flash-like memory. Actually, it is better than flash. It has much better read-write endurance, and it has much better latency. So flash, for example, can take several microseconds to write, whereas Everspin's MRAM can be written in less than 50 nanoseconds. So that's where we see a huge opportunity. The TAM over there is on the order of several $billion, and even if you get a small portion of it, 5 to 10%, that's a big deal for Everspin. But what that does, Caitlin, is it also makes the point where when you're using microseconds to write something into memory, you're using that much more power. But if you're using MRAM and you write it in nanoseconds, that's a huge power savings. So not only are you doing well for the planet through power savings, but you're also improving the performance of the system. The other thing I wanted to talk about was this huge interest in AI and especially how MRAM can impact this performance on the edge. Okay. So today what you do is you actually take the data from the servers and you transfer it to the edge, let's say your phone or something else, and the data is transferred back and forth. And every time data is transferred, you lose a lot of power or you spend a lot of power. So if you could actually have a non-volatile or a persistent memory on the edge, then you don't have to go back and forth to the servers all the time, right? So that's what MRAM can do. MRAM can actually store the information on the edge. You can turn it off because it will not lose its power. It will not lose its information. Unlike current memories today, they have to constantly refresh it to keep the memory, to keep the information. So we have two power savings. One is transfer from back and forth through the servers, and then also the refresh part of the memory. So you're saving power on two accounts, and you're making the speeds of the inference on the edge much faster because all the information is stored on the edge. And MRAM, like I said, has equal latency or low latency compared to SRAM, which is what is being used today. So it makes an effective solution. It helps the planet, and it also improves the use case for the customers.
So in short, there's a lot to be excited about when you're talking about this new and emerging technology.
Yes, that's correct. I mean, just think about it, right? Look at the buzz around AI and inference and all of that stuff. There is so much opportunity. This could be a huge market for Everspin or in non-volatile memory technology in general, right? So I think it's a great opportunity for the customers, for the environment, for Everspin to actually go after this opportunity.
That's great. There's a lot of discussion nowadays about data protection and data integrity and how that relates to memory solutions. Could you elaborate on that relationship a little bit more?
Yeah, sure. So if you're looking at this memory DRAM, for example, right, there's constant refresh that's going on. So you're actually losing power and you're also worried about data loss, right? Like we talked about data in flight, right? Same thing. So with MRAM and the systems, they basically have this architecture that manages the refresh, that manages the data in flight and what happens. So if you put MRAM over there, it actually simplifies the architecture so much. You don't need to worry about refresh. You don't need to worry about data in flight, and that makes the embedded system. So it basically, the point I'm trying to make is it actually helps with the data security and integrity because you're not going to lose it. The other part is on the flash memory, for example. What is being used today, what is NOR flash, basically the persistence of that memory actually decreases, or the data retention of that memory actually decreases over time. It's not flat. For example, if you use MRAM, the data retention is flat across the use case of the device. So whatever retention you're getting on day one, you can expect the same thing after 20 years. There is no degradation. But in NOR flash, for example, what you get on day one, after using it for even a year or so, it actually degrades to, let's say, 50%, for example. That's just a number that I made up. But it's actually continuously decreasing. So the system has to account for that and actually refresh the data or rewrite the data, or what the phrase that's used in the industry is data scrubbing. So they have to do all this data scrubbing on a regular basis to make sure that you don't lose the information in the NOR flash. So once again, over there, power loss and time, and that's where MRAM can actually play a role in helping data security and integrity in the devices that are being used. So,
Great, thank you, Sanjeev. Is there anything else that you'd like to mention to our listeners today?
yeah, I mean, Everspin is a innovative company. We are the only ones that have actually successfully commercialized two different flavors of MRAM technology, the toggle MRAM and STT MRAM. We have a very strong portfolio, 650 plus patents worldwide. So we have a strong focus on innovation and quality. And look out for Everspin for creating the next innovative device that's actually going to impact AI inference. That's going to actually replace NOR flash, standalone NOR flash devices. So I think it's a company to be reckoned with, and look out for Everspin in the future.
I will keep my eyes peeled. Thank you, Sanjeev. It has been a pleasure to talk to you.
Thank you, Caitlin. Appreciate it.
IoT Unplugged.